Hey everyone, so moving into lesson 3, we're going to look at nonlinear equations. So this may be completely new as far as systems go for you, I'm not sure. But when we solve nonlinear equations, we're still going to use the same methods that we've been using. So you can solve them with substitution and elimination. So recognizing when to use which one is key for these. So same methods that we've been using, you're going to apply those same principles. Keep in mind that a system of nonlinear equations is any system that has one or more nonlinear equations. So they don't have to all be nonlinear. So remember, nonlinear will have like an x squared in it. It might have a square root of y. It might have x times y. So any of these components will make it nonlinear. All right, so here's an example of a quadratic intersecting with a line. So that would be nonlinear because you have your x squared. And so again, you can use substitution or elimination to see where these points of intersection are. So this one is actually set up perfect for either. For example, if we multiply by 2 to the second equation, and then we subtract down, then the y's would cancel. Negative x squared minus negative 2x, those are not like terms, so that would just move here, equals negative 8. I'm going to round my 8 over and get this set to 0 because now it is a quadratic, and divide out a negative 1, and then factor to solve. So I have an x minus 4 and x plus 2. So my x is equal to 4 and negative 2. All right, well, I have two x's because I have 2 points of intersection. So I also am going to have 2 y's. My original equation said that y minus x is equal to 4. So y minus 4 is equal to 4, which means that y equals 8 when x is 4. So that's the coordinate 4, 8. Right? And then y minus negative 2 is also equal to 4. So y is equal to 2. So this would be plus. And so that's the point negative 2, 2. And so I can check that on my graph here. Here's my axis here. So here's the point negative 2, 2 is this point here. And then 4, 8 is this point here. And so you can see where those cross on the graph. So it's really combining what you know about solving quadratics and nonlinear equations into a system. You can also use substitution to solve. So recognizing the fact that here I could use elimination, but I could also solve one of these equations for either x or y. So let's solve this bottom one for x so you can see what that looks like when we need to expand. So we have x equals y minus 3. And we're going to take this and we're going to use substitution here. And substitute it into the first equation. So x squared plus, oops, sorry, I circled the wrong thing. We solved for x, so we're going to plug it into the first equation here. So y minus 3 squared plus y equals 9. And for this particular problem, I'm doing it a little bit more of a complex way just so you kind of get the idea here. this squared is y squared minus 6y plus 9. Please make sure you FOIL it. Plus y equals 9. I got that from taking y minus 3 times y minus 3. The 9's will cancel. The y's will combine, so I get y squared minus 5y equals 0. Factor out. So y will equal 0 and y equals 5. So because I have two y's, I will also have two x's. I'm going to go over here and plug this in. So x equals 0 minus 3 and x equals 5 minus 3. So the negative 3 goes with the 0. So I have the coordinate negative 3, 0. And then 5 goes with the 2. So that's the coordinate 2, 5. Right, so those are both points of intersection. You can always graph that on a graphing calculator and check that to see where they cross. Right, but again, just emphasizing that you can use regular elimination with this as well. So again, this one's already kind of lined up to do that. We have x squared, we have y squared, so you can eliminate either. The y squareds are already the same, so I'm just going to subtract down. X squared minus 2x squared is negative x squared. The y squared can cancel. Think of this as nothing minus x, so I get a negative x, and then 1 minus 3 is negative 2. So remember, you're combining like terms here, even if they're not one over the other. For some reason, that confused some of you guys with long division. So even if it's not lined up, you can only combine your like terms. This is a quadratic, so I need it equal to 0. I'm going to add the x squared over, and then I'm going to factor, and then I'm going to solve. So x equals 2, and x equals negative 1. Again, with those two answers, I need to find my y values as well. And so I'm going to plug those in up here. So I get 2 squared minus y squared equals 1. So that's 4. So negative y squared equals negative 3. Y squared equals 3. And y equals plus or minus the square root of 3. Okay, so for that, we plugged in, remember we plugged in 2, so we have the point 2 square root of 3. And we also have the point 2 negative square root 3. And we want to find this value here as well, so we do negative 1 squared minus y squared equals 1. So 1 minus y squared equals 1. Negative y squared equals 0, so y equals 0. So we're also going to have the point negative 1, 0. So these are all of the zeros for this, not the zeros, sorry, all of the points of intersection for this system. And so if you look at the graph of this, and I went ahead and typed it into Desmos, you can see this top one is a circle. Oh, what did I do? There it is. This top one here is a circle. The bottom one is a hyperbola, and we'll talk about those in a unit coming up. That's my stylus. And so they cross at these 3 points here. There's a point there, there, and there, where they have a point of intersection. So if you type in I typed in something wrong here. I did. This is minus. Okay, there we go. So we have this point, there we go, and then the 2's. That's not a circle because it's subtraction. So that was my fault. So you have 2. If you type in square root of 3 into your calculator, you'll see that you get about 1.732 and so on. So you have those 3 points of intersection. So you can always double check on a calculator, but I do want you working these out algebraically. Okay, so again, just emphasizing that you can check these in a calculator. In order to graph a circle in your graphing calculator, to check these points, so you can solve this with substitution by taking this x and replacing it with the y squared. So you have x squared plus x equals 4x. So x squared minus 3x equals 0. So x equals 0 and x equals 3. And you can see here at 0 and at 3 are those points of intersection. You then find the y values by plugging this in. So 0 equals y squared. So y equals 0. So there's that point 0, 0 right here. 3 equals y squared. So y equals plus or minus the square root of 3. That would be these points here and here. So you would have 3 root 3 and 3 negative root 3. So you can confirm that on your graphing calculator. But to graph this, I wasn't recording for a second. To graph this, you can't graph a circle in your graphing calculator, so you have to solve for y. All right, actually the same is true for this. And so you get y squared equals negative x squared plus 4x, and then y equals plus or minus the square root of negative x squared plus 4x. So in your graphing calculator, you're going to do both the positive and the negative of this, and then when you graph it, it should be the circle. Okay, same thing for the second equation. If x equals y squared, then in your graphing calculator, you're going to type y equals the square root of x and y equals a negative square root of x, and it will give you this sideways parabola. So just a tip on that. I'm not going to walk through all of these, but just wanted to show you some different examples of what nonlinear systems could look like. And then like the best methods to solve these. Like for this, for example, there's no x or y down here. So you could multiply through by x, or you could square both sides of this to get those to where you can use elimination. But for this one, I would use substitution. Whereas for this one, I would probably use elimination because I could subtract the x and square both sides. Or I can square both sides and FOIL. Actually, I'm taking that back now. I would do that, but doing that gives you y, and then you can just plug y in. Where here, when I have these matching terms, I would use elimination. So recognizing what might be easiest to use. They both will work, but recognizing what is easier, right? So ask yourself, what method is easier? Okay. If I ask you to do one and round it, this is just a graphing calculator. All right, so okay, so make sure you get both of these graphing calculator ready. So solve for y if they're not already. And then you type them in to the graphing calculator. And so y equals negative square x squared plus 12 and negative square root negative x squared plus 12. So that's the plus or minus in it. And then the second one. couple cautions about the graphing calculator. For some reason, even with circles, it doesn't connect them all the way. This also doesn't look like a circle, and that probably has to do more with something in my window, even though it's counting by the same amount, so I'm not sure. So you can kind of see on the graph itself, my x-axis is spread out more than my y-axis. That might have something to do with this number that I never really mess with. Let's try that. Yeah, I messed up even more. Anyways, so it doesn't always connect in a circle. So if you look at Desmos, for example, here's the actual circle. And you can see it's a perfect circle. So just be cautious of that. You have to understand your parent functions and that this is the equation of a circle when you're graphing it. Reference Unit 1 notes for that. In your graphing calculator, now I need to see if I can fix my window. You can find your point of intersection. I think it was something like that. I'm not sure. By hitting second trace, let me let it finish graphing here. You could also see in Desmos that these don't actually intersect. So we had second trace, intersect is number 5. And it's going to say first curve. And this one, the first curve is on the circle. Go close to whichever point of intersection you're looking for and hit enter. And then it's going to jump to the second curve. Oh, and I didn't go to the right curve. Yeah, I know. Okay, sorry I had to play with it. I don't think I've ever had more than one function in there. So up at the top of the calculator, I'm not sure how well you can see my screen, but up here it's telling you which curve is which. So the first curve was my blue one, and I want to know where it intersects with that black one. And so I need to use my down function and scroll to it so that it says Y3. That's because that's where I have it typed. Now I can hit enter. It will have your guess down at the bottom here. And then you hit enter again. And it will give you your point of intersection. Okay, and you can do that on both little points. All right, so that's all in that functionality. Okay. And I think I'm actually going to end it there for today. And we'll do applications tomorrow. So wait on this one. Actually, I'll probably just go ahead and delete it off your template. So go ahead and do the assignment for those and have a good night. Good day.